Hello guys, welcome back to our channel Chemistry with Coffee. Today we are going to learn about IUPAC nomenclature of organic compounds. By the end of this video, you will be able to name simple to complex alkanes, alkenes and alkynes. Let's look at the alkanes. Alkanes have a general formula of CnH2n plus 2. Alkanes have CC single bonds. So before understanding IUPAC rules, please remember these root names for different carbon atoms. If one molecule has one carbon atom, we use the root word meth. If the molecule has two carbon atoms, we use eth. Same way, if the molecule has 9 carbon atoms, we use non as root name. And if it has 10 carbon atoms, we use dec. If you look at the C2H6, this molecule has 2 carbon atoms, so we are going to use eth as the root name. And if we substitute n is equal to 2 in this general formula, 2 multiplied with 2 is 4 plus 2 6. So H6. So this molecule satisfies the alkane general formula. That means this molecule is an alkane. So we will use ane as the suffix. So ethane. So ethane. Similarly, we can name the different alkanes as here. For example, if we are going to name the C6H14 molecule, this molecule has 6 carbon atoms, so we are going to use hex as a root name. Hex plus, if we substitute n is equal to 6, that is 2 multiplied with 6, 14. Sorry, 2 multiplied with 6, 12 plus 2, that becomes 14. So C6H14 molecule satisfies the alkane general formula, or this molecule is an alkane. So we are going to use ane as a suffix. So combine hex and ane, so it becomes hexane. So let's see. So in the IUPAC nomenclature, first we need to understand how to choose the parent chain. So in IUPAC nomenclature, we need to understand or learn how to number the parent chain. So parent chain means the longest carbon chain in the molecule. So if you look at this molecule, so you can number from top left to the top right, or bottom left to the bottom right, or you can go this direction or this direction. So we choose the path so that we will get a maximum number of carbon atoms in the parent chain. If we follow this path, we will get maximum number. That is, let's count it: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If you follow this path, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you follow this path, we are getting 12 carbon atoms. If you follow this path, we are going to get 10 carbon atoms. So we choose this is as our parent chain. Similarly, we will solve for these molecules. So for the straight chain alkanes, the name will be, first we need to count the how many carbon atoms are there in the carbon chain, plus we add the suffix. So in this molecule we have 8 carbon atoms, so we are going to use oct as a root name. And this molecule doesn't have any multiple bonds, that is double or triple bonds. So all these molecules have is the single bond. So we are going to use ane as a suffix. So oct plus ane, octane, is this molecule name. So for naming the branched chains like this one, there are certain set of rules. First rule is choose the longest carbon chain as the parent chain. For example, if we see the 5th molecule, so we can number from top left to the right side, like as shown here. If you follow this path, we will get 9 carbon atoms, or you can go from this direction, bottom left to the top right. So let's see how many carbon atoms we will get. 1, 2, 3, 4, 5, 6, 7, 8, 9. Same 9 carbon atoms. So but why we are choosing this path? Because this path, if you follow, we will get 4 substituents. That is a 1 bromine, 2 ethyls and 1 methyl. Or if we follow this path, we will get only 1 and 2 substituents. That's why we are following this path. That answers the second one. If substituents attached, choose the one with more substituents. So we are choosing this path because this parent chain contains more number of, that is 4 number of substituents. If substituents, we already covered this one. Let's see the third one. If only one substituent is present in a molecule, substituent should get less number. For example, if we look at this third example, if we start numbering from left side to the right side, the chlorine gets 2 number. Or we can do from right to left. In that case, 1, 2, 3, 4, 5. The chlorine gets 5th number. So we need to make sure the substituent gets less number. So we follow the left to the right while numbering. Let's see the fourth one. If a molecule contains 2 or more identical substituents, we use di for 2, tri for 3, tetra for 4, penta for 5, etc. Let's look at this 9th example. So in this example, we are numbering from left to right. While numbering, this first methyl getting second position. If we are numbering from right to left, same, this methyl also gets second number. So in that case, we continue to number and see the third substituent's number. So if we follow the numbering from left to right, this substituent, this methyl substituent gets 4th number. And if we number from right to left, this methyl gets, let's see which position it gets, 1, 2, 3, 4, 5th number. That's why we are numbering from left to right. Okay, so this molecule contains methyl substituent, 3 methyl substituents at 2nd, 4th and 7th positions. So we name this as 2, 4, 7 tri because this molecule contains 3 methyl groups, trimethyl octane because oct for 8 number of carbons. En means because this molecule contains only CC single bonds. Okay, if 2 or more different substituents are present in a molecule, first substituent gets lower number. Let's look at the 7th example. The 7th example, if we start from left, the methyl gets second. The first substituent from left is methyl, it gets second number. Or we can do from bottom to the left. So we start from bottom, this ethyl is a first substituent. So 1, 2, 3, 4. So that's why we are following left to right. So methyl is getting second position and ethyl is getting 4th position. If 2 substituents are at the same positions from either ends, assign less number to the one that comes first in the alphabetical series. Let's look at the 6th example. In the 6th example, if we start numbering from left, so second position gets chlorine. If we start numbering from right, bromine gets second position. In that case, we number from right to left because bromine, so B is before the alphabetical series of chlorine C. So B gets first, right, after chlorine. So B gets first, then chlorine C. Okay. So let's name all the molecules. So let's look at the first molecule. So we are numbering from left, that is the top left to the top right, because this is the carbon chain contains maximum number of carbon atoms, that is 12. So this has 2 substituents at 3rd position and 9th position. So out of these 2 substituents, ethyl comes first in the alphabetical order, then methyl. So ethyl starts with E, methyl starts with M. So E, then M, right? So first we write the location of this substituents, that is a 9-ethyl and then 3-methyl. So it contains 12 carbon atoms. So we use dodec for 12 carbon atoms. And this is an alkane, right? Only CC single bond, so we use N. Let's look at the second example. In the second example, we are numbering from bottom to the top left. You can number from left to right, but that is not correct way, because in that case, if you start numbering from left to right, this methyl gets 1, 2, 3, 4, 5. If you start numbering from bottom, it gets 3. So according to IUPAC rule, substituents should get less number. That's why we are naming from this direction. So start naming from substituents. So 3-methyl heptane, hept for 7 carbon atoms, and this is an alkane, that's why we put ane. So third one. So in this molecule we are numbering from left to the right because the chlorine substituent is present. So we are making sure this gets less number. So 2-chloro, 6 carbon atoms, hex, alkane, so ane. Let's see the fourth one. Fourth one, very simple one. This molecule has 8 carbon atoms, so oct, alkane, ane, octane, or we can use n-octane. N-octane means unbranched. Let's look at the fifth example. So this molecule has 4 different substituents. One is a bromine, second category is a ethyl, 2-ethyl, and 1-methyl. So in alphabetical order, bromine gets first, then ethyl, then methyl. So first we write 2-bromo, then ethyl, right? 3,7 diethyl, and then methyl, 8-methyl, and 9 carbon atoms, so none, and this is an alkane, so ane, nonane. Let's see the fourth rule. If 2 or more identical substituents are there, we use di, tri, tetra. So we have already covered these rules, right? Let's name these compounds. So we are naming the 6th molecule, we are numbering it from right to left. So this substituent, first we write 2-bromo and then 6-chloro-heptane because 7 carbon atoms, and this is an alkane. Because we are following alphabetical order, right? Bromine comes first, that is a B, then chlorine C. 7th one, we are numbering from left to the bottom. So we have 2 substituents, that is a methyl and ethyl. So ethyl comes first in the alphabetical order. So 4-ethyl, 2-methyl, and 7 carbon atoms, that is a hept, and alkane, so ane. 8th one, this has 9 carbon atoms and 2 substituents. So bromine and methyl. We are numbering from left to right because bromine comes first in the alphabetical order, right? That's why this should get less number than methyl. If you start numbering from right to left, methyl gets 2 number. If you start numbering from left to right, bromine gets second number. So bromine comes first in alphabetical order. So we are doing from left to right the numbering. So 2-bromo, bromine comes first in the alphabetical order, and then 8-methyl, nonane because 9 carbon atoms, right? And this is an alkane, only single bonds. Coming to the 9th one, so this has 3 substituents, that is a methyl substituents at a 2nd, 4th, and 7th. So 2, 4, 7, trimethyl because 3 methyl substituents are there, and this molecule contains 8 carbon atoms, so oct, and this is an alkane, so ane, octane. Okay, so in this slide we are going to name the branched substituents. That is, this is a molecule, right? This molecule has a branch. These are called branches. So if this branch is complex one, we have to name this one also. Okay, so assign first number to the substituent's carbon attached to the parent chain. So in this substituent, this carbon is directly attached to the parent chain. So this carbon gets first number, then second, then third, or you can do 1, 2, 3. Both are same. Okay, so let's name it. So first, in this substituent on the first carbon, it has ethyl again. So we write 1-ethyl. This has 3 carbon atoms. So propyl. We should not write propane because this is a substituent. So 1-ethyl propyl is the name for this substituent. So let's name it completely. We are numbering from right to left, so as to get the substituent get less number. So this name is E, these are methyls, right? M. So E comes first in the alphabetical order, then methyl. So 5 1 ethyl propyl, 2, 4 dimethyl. So while considering for the alphabetical order, we should not consider di or tri or tetra like that. So dimethyl undecane. Undec means 11 carbon atoms. An means this is an alkene. So while considering the alphabetical order, we only take iso and neo into consideration, but not the secondary, tertiary, di, tri, tetra. Let's look at the 11th molecule. In the 11th molecule, we are numbering from top to the bottom. That is the top right to the bottom left. We are doing so in order to get less numbers to the substituents. So this substituent is a little bit complex. Let's name this first. This substituent, this carbon is directly attached to the parent chain. So this carbon gets first number, then second number, third number, fourth number. Or you can do 1, 2, 3, 4. Both are same, right? So this substituent again has a small branch or substituent. So on second position we have ethyl. So second position in the bracket we are writing this complex substituent. So 2 ethyl, and second position we have ethyl, and this has 4 carbon atoms. So butyl, not butane, because this is a substituent. So that's why we write butyl. So 2 ethyl butyl is the name for this substituent. So this is present on the 8th carbon, right? So 8th carbon, 2 ethyl butyl, 5, 5 dimethyl, pentadecane. So 15 carbon atoms. The name is pentadec for 15 carbon atoms, and alkane en. So we are writing this substituent before the dimethyl or methyl. So methyls M and E. So E comes first in the alphabetical order, then M. That's why this has a priority while naming the molecule. Let's look at the alkenes. So alkenes have carbon-carbon double bonds, or an alkene molecule should have at least one CC double bond. So and also they follow the general formula CnH2n. Let's look at the C2H4. So this molecule has 2 carbon atoms. So we use the root name ETH. If you substitute N is equal to 2, 2 multiplied with 2 becomes 4. So this molecule satisfies this general formula of alkene. So ene, we add ene. So this molecule becomes ethene. Same way, this molecule's name is propene, butene, pentene. Let's name the C9H18. So this molecule has 9 carbon atoms. So 9 carbon atoms means we know the root name is known plus. Let's substitute 9 number in this general formula. N is equal to 9. So 2 multiplied with 9, 18. So this molecule satisfies alkene general formula. That means this is an alkane. So we put the suffix -ene. So this molecule name is nonene. Okay, so few more rules. In alkanes, the parent chain must include the double bond, and also double bond gets priority over other substituents and gets lower number. So let's look at this one, second molecule. In the second molecule, you can number from top to the bottom right, or you can do left to right. If you can do left to right, this includes a double bond, or you can do top, that is from this methyl to this methyl, that is a top to the bottom right. But if you follow this path doesn't include a double bond. So this is not correct. The parent chain should include a double bond. So that's why we are following this path. That is and one more thing, while doing, you should not number from right to left. In that case, this double bond carbon gets which number? Let's see, 1, 2, 3, 4, 5 number. If you start numbering from left to right, this double bond carbon gets first number. So this double bond carbon should get less number possible while numbering. So that's why we are numbering from left to the right. If a molecule has more than two or more double bonds present, we use adiene or atriyne. Let's look at the fifth example. In the fifth example, this molecule has 2 double bonds. So we start numbering from left to right so as to get the double bonds less number. 1 and 4. If you start numbering from right to left, you will get bigger number for these two double bonds. That's why we are numbering from left to right. So in this case, so there are two double bonds at first and fourth position. So this molecule has 7 carbon atoms. So we are using hept, and also we add a, hepta. So hepta, and first and fourth position we have two double bonds, 1, 4, diene. So make sure you are putting a for 2 or more double bonds. So hepta 1, 4, diene. Okay. Let's name the compounds from first to the fifth. For the first one, we are numbering from left to right so as to get the double bond less number. If you start numbering from right to left, this double bond gets fourth number, right? That's why we are doing from left, this is getting first number. This molecule has 5 carbon atoms, so we use pent as root name, and double bond is present on first carbon, so pent 1 ene. For the second one, we have already discussed this one. So it has a substituent at the third position, 3 ethyl, and double bond is present on first carbon, but this has 6 carbon atoms. So first, let's look at the ethyl first, 3 ethyl and 6 carbon atoms, hex, and first position double bond 1 ene. You should not put hexa because this molecule only has one double bond. This molecule has two double bonds, that's why we are using hepta. We are adding a. Let's name the third molecule. In this molecule, we are numbering from right to the left, not from left to the right. If you start numbering from right to left, this carbon gets less number, and also this substituent. First name the substituents. So at second position we have methyl, 2 methyl. This has 7 carbon atoms, hept. And third position we have double bond, 3 ene. For the fourth one, start numbering from left to right so that the substituent and double bond gets less number. So second position we have methyl, so 2 methyl, 5 carbon atoms, pent, second position double bond, 2 ene. These molecules we have already discussed. Let's do it one more time. So numbering from left to right so that these two double bonds get less number. So this has 7 carbon atoms, so hepta, we are adding a. We are adding a because this molecule contains 2 or more double bonds. So hepta, so double bonds are present on first and fourth position, 1, 4, diene. Okay, so let's look at the alkynes. Alkanes have general formula of CnH2n-2. Alkane molecules contain at least one triple bond. So let's look at this molecule C2H2. So this has 2 carbon atoms. So we will use eth as the root name, eth, and let's substitute n is equal to 2. So 2 multiplied with 2, 4, minus 2, 2. So this molecule satisfies the alkyne general formula. So the name is ethyne. Let's name this molecule C10H18. C10 means dec is the root name, and let's substitute n is equal to 10. So 2 multiplied with 10, 20, minus 2, 18. So this molecule satisfies the alkyne general formula. So we put suffix -yne. So this molecule name is decyne. So for the alkynes, the rules are similar to the alkenes. Parent chain must include triple bond and should get less number. Let's look at the third example. In the third example, you can number from bottom to the top. In that case, this path doesn't include the triple bond. That's why we are following left to the top right. And while doing so, we are numbering from left to the right, not from right to the left. If you start numbering from left to the right, triple bond gets second number. Or if you start numbering from right to the left, triple bond gets let's see 1, 2, 3, 4, 5 number. So that's why we are numbering from left to the right. So usually double bonds and triple bonds get equal priority, but if they are at the similar positions from either ends, double bonds gets priority. For this molecule, first molecule, so start numbering from right. to the left, because this first multiple bond gets first number. If you start numbering from left, this double bond gets 3 number. So functional group should get less number. So that's why we are numbering from right to the left. In that case, triple bond gets first and a double bond get fourth position. Let's look at the second molecule. In second molecule, if you start numbering from right, double bond gets first position. If you start numbering from left to the right, triple bond gets first position. In that case, double bond gets priority. And these molecules are en-yne molecules. So we omitted the E, second E, E-N-Y-N-E. Similarly to the alkanes, if 2 or more triple bonds are present in a molecule, we use the suffix adiene, atriyne, etc. Let's look at the fourth example. In the fourth example, we have 2 triple bonds. So you can number from left to right or right to left, both become same. So we have 2 triple bonds at first and sixth position. So this molecule has 7 carbon atoms, so hepta, 1,6, triple bonds at 1 and 6 position, right? Diyne, so hepta 1,6 diyne. Okay, so let's name all the molecules one more time. So first molecule we are numbering from right to left for the functional group to get less number. So hept for 7 carbon atoms. Fourth position we have ene, so we omitted the ene, the second E, and first position we have yne. So this molecule's name become hept 4-in 1-yne. For the second one we are numbering from right to left because double bond gets priority when double bond and triple bond have equal positions on either ends or same positions. So hex, 6 carbon atoms, hex, 1 ene and 5 yne. Always write double bond first followed by triple bond. That is the ene and then yne. In ene, remove the second E. Third molecule we have already named this one. So this molecule has a propyl functional group, that is a substituent, non-functional group substituent. So this has a propyl substituent, so we write 4 propyl and 7 carbon atoms, right? Hept, and second position we have triple bond, 2 yne. Coming to the fourth one, we have already discussed hepta 1,6 diyne, because 1 and 6 position triple bonds. We are using A, hepta, not hept. For the fifth molecule, so we are numbering from right to left because the functional group should get less number over the other substituents. So this has 3 different substituents, fluoro, chloro, bromo. In alphabetical order, bromine gets first, chlorine gets second, fluorine gets third. That is a B, C, F. So 7th position we have bromo, 7 bromo, 3 chloro, 6 fluoro, 7 carbon atoms, hept. We have 4 ene, double bond at 4, and first position we have triple bond. Okay, so we have finished the basic IUPAC rules for alkanes, alkenes and alkynes. Let's have a review. So please pause the video and look over the rules. When you are done, continue to the next page. Okay, these are the problems for you to work on, that is for practice. Please solve it and post the answers in the comment section below. I will post the correct answers within 7 days. Thank you very much guys. Please let me know if you have any questions in the comment section below. See you all next week. Don't forget to like and subscribe to our channel Chemistry with Coffee.